Hey guys, before we had a problem one, which is actually, that was a bit tricky, and that's why I decided to highlight all nuance and details. So make sure you watch the previous video. And we'll go next. So this is first a trigonometry and trigonometry with compound shapes. So that was problem one. So the link in description below. So make sure you watch that. And we go to the next problem that I consider also tricky one. This is definitely higher maths or IGCSE extended. So let's have a look, grab your pen and papers, try to do by your own, and let's get started. All right, so we have a known shape. So let's have a look. We have a known sides A and B that we're actually supposed to find them. However, let's have a look at the shape. So the complete shape, it looks like trapezium, so that's definitely quadrilateral. However, we are not sure about that angle. So it seems to you guys, for many, it might seem that this is 90 degrees, so right angle. However, it's not, because the shape might be drawn not to scale. So that's why let's just try to define the first angle right in the corner. So let's try to define this angle first. Okay, so here is the angle. What we need to do, we know that because it's quadrilateral, the sum of all angles, so I can write that sum of all angles in quadrilateral is 360. All right, I hope you remember this formula, n minus 2 times 180. That's going to be the formula, stays for the sum of all interior angles in the polygon. However, I hope you know that for quadrilateral, you can just memorize this figure 360. All right, so from where we can find that this angle is simply, maybe let's set up as some unknown for a while, x. Yeah, we didn't have that, so angle x is simply 360 minus all the angles, minus 90 degrees, minus 120. And if I add 1329, we need to subtract 59 degrees. All right, so having that, we find that angle x is going to be, let's just calculate. So 360 minus 90 minus 120 and minus 59. So I've got 91. So now we know that this angle is simply 91 degrees. Okay, so now we understand that it's just 1 degree away from 90 degrees or from right angles. So however, this is the case and we cannot like round up. So, and that's why it seemed to you guys that it's as if 90 degrees. However, it's not in reality. Okay, so what we can do, let's consider that small triangle, the top one. So let's set up some letters A, B, and C. So let's consider triangle A, B, and C. So it's not right angle, so we're not able to apply. However, we can apply sine rule or sine theorem. So what it means, we need to find side A, which is unknown, but we know that it's opposed 90 degrees. Sorry, my bad. It's opposed 29, so that's opposed 29 degrees in this triangle. And what we also know, we know that 20 centimeters is opposed to that angle, which we can find easily. So this angle is actually 180 minus 29 and minus 91. So if we calculate that, so we'll get is how many? 60 degrees. So this small angle is 60 degrees. So we can write that as 61. So 60 degrees here. So that's why we know that 20 is opposed to 60 degrees angle. And we apply sine theorem. So sine theorem for that triangle. So sine theorem tells you that if you take 20 and divide to the sine of the angle that opposed to that side is sine 60, you'll get the same as A. That will be the same as A opposed to 29. Not 29, sine of that 29. So that's what your sine theorem tells you. So that's very significant. And first in this problem, we use that. All right, so how to resolve this ratio? We're gonna do just crisscross. So our unknown is A, so we can express A as sine 20 by 20, sine 29, sorry, sine 29 by 20, and over sine 60. Okay, so from where we can figure out A in centimeters immediately. Okay, so let's calculate. So 20 times sine 29 and over sine 60. So I've got around 11.96, so it's going to be 11.22, one decimal place, so centimeters. So that's why we can say approximately 11.2. And this is going to be a solution for A part. So we've got A. So next part, we need to find B. Okay, how to do this? For the first glance, we might calculate this angle. This angle is 30 degrees, and we'll find out that both sides are actually the same if you consider triangle AC and let's say D. So in the triangle AC and D, so we will have that this triangle is isosceles. So that's why this is also B centimeters. However, does it give you something? I'm not sure. So it's not enough. Yeah, if you put height, so you don't know height anyway, you don't know the opposite side, and you don't know any side, you know only the angle. So triangle ACD is not helpful. So it doesn't help. So what we're gonna do, I think we need to put the height. I mark as blue one. So from point C, right there. Oh, so actually, yeah, because it's 91 degrees, it will be very, very tiny angle. But let's pretend that we draw the height from here to here, and we set up that point, let's say as K. So let's consider triangle KBC, KB and C. It's 90 degrees, so 90 degrees at K, at the point K. So we have a very, very narrow triangle. However, we know that angle here is 91. So actually we will have triangle with small angle here, which is 91. Yes. How it's supposed to be if it's 91? It means that, yeah, so that triangle is gonna be on the other side. But okay, it doesn't matter. Yeah. So guys, actually the height in this case is not gonna be like that. So yeah, if it's 91, definitely what we are going to say. We are going to say that the height will be behind. So that's why point K is going to be somewhere here. Yes, because if the angle is 91, we're now eligible to use that because it's more than, so in the right angle triangle, it's not going to be angle more than 90 degrees, right? So that's why we put the point K on the other side. So let's rearrange them. So that's point B. We put the height. So that's going to be height to the segment AB. And if we prolong a little bit, so we'll get, if we prolong that side, we'll have small triangle. And because this angle is 91, the rest part, this angle, this small angle, is going to be 89 degrees. So, and this point is K. So we will consider small triangle. I will draw not to scale, but it will look like, so, like this. Okay, like this. That's going to be a triangle C, K, and B, with angle B to be 89. So this angle is 89 degrees. So from where we can find KC, which is a height, okay? Because this angle is 90 degrees. So let's find KC. So KC to, let me see, we found A, right? So we found A, so this is A, 11.2, so we know that. And this is A, 11.2. And this is hypotenuse, so we can figure out KC is height. So KC, which is actually height, from where? We can use sine 11.2 times sine of the angle 89. So sine angle 89. Now let's calculate. So 11.2 times sine of 89. I will get around, wow, we've got around, yeah, so to one decimal place, even to two decimal place, we got the same height. Okay, so if you consider more precisely, so we can say that actually height, in this case, is almost A if you consider two decimal place. Oh, so that's why we'll get 11.2 as well. Yeah, definitely the angle is quite small. I mean, sorry, the angle is very close to 90 degrees, so that's why hypotenuse and actually A are practically indifferent, so they have the same values even to two decimal place, because I've got 11.19. If you round up, you'll get 11.2. So if you consider that, oh, that's much easier then. So you can say that if you drop the same height here, okay, and you will have here 90 degrees angle. So let's set a point M in the triangle AMD, MD, you'll have this angle to be 59 in total, 1329, and you have right angle triangle with this side to be the height, which is actually approximately 11.2. So if we use that, we can figure out B. So that's our target's variable right now, so we want to figure out B. So B is hypotenuse, right? And in this case, what we can do, so if we consider AMD, it's right angle, so B is hypotenuse, so we have the opposite side, opposite leg to the angle 59. So that's why we will complete 11.2 will be equal to B times sine of the angle 59. Okay, so from where we can figure out B as 11.2 over sine of 59. And if we calculate that, so 11.2 over sine of 59, we'll get 13.1 centimeters. 13.1 centimeters, and this is the target value for the other side that we're looking for. So two answers. answer 1, so A is 11.2 and B is 13.1 centimeters. So I can rewrite that finally. B is 13.1 centimeters, and we finally found that. Okay, so that's the second answer. All right, yeah, I understand that was pretty hard because you need to take into account different aspects, and even in the last case when we considering the height, so that to transfer the height here to arrange triangle, we mixed up a little bit with height because the height was approximately equal to A. Yes, and because of the small difference between 91 angle and angle of 90 degrees, we will have actually this angle very, very small. All right, so actually, yeah, so this angle to be very, very small, almost zero in this case. Okay, so hope you like that and you understand the idea of rounding, so that you can believe that A is almost the height. So make sure you understand that, you understand this approach, and that was the answer. That was the answer. All right, hope you like that. Don't forget to subscribe if you're new here, and see you later.